Okay. Good morning, students. Today we'll discuss long answer question from oscillation lesson. That is the question number 4. I said in my previous class, total 6 questions. From intermediate first year, you are reading 6 LAQs. Up to now, 3 LAQs over. First question, law of conservation of energy freely falling body. Second question, define work, kinetic energy, work energy theorem. Third question, time period of simple pendulum. Now, fourth question. Today, I am giving clear-cut explanation about SHM. Fourth LAQ question, SHM. Define SHM. Simple harmonic motion. Define SHM with particle motion is SHM when a particle moving in circular path with respect to diameter, its motion is SHM. So, define SHM, simple harmonic motion. Particle motion is SHM in circular path. So, student, focus on fourth LAQ, SHM, simple harmonic motion. SHM, simple harmonic motion. So, simple harmonic motion means periodic motion. Periodic motion. A periodic motion. Periodic motion means a motion which repeats in regular interval of time. So, periodic motion means a motion which repeats in regular interval of time. One periodic motion with two conditions. One is to and fro motion. To and fro motion. A motion is SHM. A motion, we are saying simple harmonic motion, meaning ordinary periodic motion with two special conditions. One is the to and fro motion. To and fro motion. Next one, acceleration directly proportional to displacement with opposite direction. Acceleration directly proportional to displacement with opposite direction. A directly proportional to minus y. Ordinary periodic motion with two special conditions. One is the to and fro motion. Next one is their acceleration directly proportional to displacement with opposite direction. Acceleration of the body always acting towards its mean position. So, you are writing SHM definition, a periodic motion with to and fro. And one more, acceleration directly proportional to displacement with opposite direction. These two conditions satisfies means that motion we are calling SHM. On removing proportional, we can get constant, that is omega square y. Minus indicates that acceleration and displacement both are in opposite direction. So, question they're asking, define SHM, simple harmonic motion with a particle moving in circular path with respect to its diameter. The motion of particle is SHM. SHM definition, periodic motion with two conditions, to and fro motion. Next, acceleration directly proportional to displacement with opposite direction. These two conditions belongs to SHM. Now we'll show what is the particle motion SHM in circular path. So student, SHM means these two conditions, a periodic motion to and fro like this. Acceleration directly proportional to displacement with opposite direction. Now circular path. This is the circle. Take now say here one particle moving with omega angular velocity in circular path. You know, these are the diameters x, o, x dash, y, o, y dash. A particle moving in circular path with omega angular velocity. This is take A, nothing but maximum displacement amplitude we are saying. So we are getting two right angle triangles. This is the angle theta. This one theta means obviously this one also theta. This is A, angle theta, and this is Y. So O, A, B. O, A, B. We are getting like this. See. O, A, B. What is this? O, A, B, one right angle triangle. O, quite opposite, theta, quite opposite, OB. So, student, like this. Here, from this one, sin theta means opposite side by hypotenuse. So, opposite side by hypotenuse, sin theta we are calculating from triangle OAB. From triangle OAB, sin theta means opposite side Y by hypotenuse. A. Y equals to A into sin theta. This is the displacement equation from triangle OAB. From this one, y is equal to A sin theta. What is the theta means? Angular displacement. What is the angular displacement instead of omega means? Angular velocity. You know very well about ordinary velocity. Ordinary velocity means velocity equals to displacement by time. Angular velocity omega equals to angular displacement by time. Omega equals to theta by t. Theta equals to omega t. So theta equals to omega t. Substitute here. We can get our equation number 1. Y equals to A sin omega t. Equation number 1. This equation number 1, displacement. We need acceleration from this circular path. This question, simple harmonic motion with a particle moving in circular path with respect to its diameter, its motion is SHM. So y equals to A sin omega t, differentiation with respect to small t, time. What is the y differentiation? Dy by dt equals to A, obviously constant. We are not doing integration come differentiation constant value. For example, differentiation, we are doing differentiation constant. Always constant differentiation or constant integration, we can get 0. A nothing but here radius. That one only we are saying according to our topic, maximum displacement amplitude. So dy by dt equals to A, obviously out d by dt of sin omega t. This one I am giving overall explanation. Then after next step, I will give you short method how to write this answer in short way. dy by dt, rate of change of displacement, nothing but velocity. A obviously constant. D by dt of sin omega t. Obviously, MPC student, they know d by dx of sin x, cos x. Here, d by dt of sin omega t, meaning omega cos omega t. This is the mathematical formula. V equals to A omega constant outside, cos omega t velocity. We need acceleration, meaning two differentiation. First, displacement differentiation. Rate of change of displacement, velocity coming. Again, rate of change of velocity. We can get our equation acceleration. V equals to A omega cos omega t. Again, differentiation. Then what is the next step means? A V equals to A omega d by dt of previous step only students here. V nothing but left side dv by dt. A omega, A constant, omega constant, bracket cos omega t. So this is dv by dt, A omega constant, cos omega t. Then what we are getting? Rate of change of velocity, nothing but acceleration. A omega obviously constant. What is the d by dt of cos omega t? Minus sin omega t. Minus sin omega t into omega. So this omega outside, minus outside. A omega into omega. Omega square. Sin omega t. This is the A formula after differentiation. So we are writing A sin omega t. Previous case, y equals to A sin omega t. Here we got A sin omega t, meaning minus omega square. As usual, we are writing A sin omega t, nothing but y. Bracket you write like this, y equals to A into sin omega t. So student, A equals to minus omega square y, A directly proportional to minus y. This condition only SHM. So from that circular path, we are getting acceleration directly proportional to displacement with opposite direction. One more time, I am giving explanation. Next time you listen this total answer in short way. Very few steps. Within few steps, we are finishing. First, SHM, simple harmonic motion. Question starts from definition of SHM. Define SHM. Particle motion SHM when a particle performing in circular path. SHM, simple harmonic motion. A periodic motion with two special conditions. One is to and fro motion. Second one, acceleration directly proportional to displacement with opposite direction. If you remember, they are going from X notation also. Both are same. On removing proportional, constant coming omega, angular velocity. So SHM formula, A directly proportional to minus 5. That y equals to A. On remove proportional, we can get constant. SHM formula, A equals to minus omega square y. Then after circular path, one particle moving in circular path. This is anti-clockwise direction, student. What is the angular velocity means? Omega. Particle moving from here x to some A point, it takes some t time. Here we are drawing imaginary diagram. Two right angle triangles coming. This is angle theta. Here also theta there. So ABO, from right angle triangle ABO, what is the sin theta means? Opposite side. Opposite side means y by hypotenuse A. Y equals to A sin theta. Angular velocity equals to angular displacement by time. Angular displacement equals to omega t. Substitute here. Equation number 1. That equation number 1 indicates that displacement of the particle. Again, differentiation. Why we are doing differentiation means when we are doing differentiation, rate of change of displacement, meaning when we are doing differentiation, from this displacement we are getting velocity. Again, one more displacement, double differentiation, we can get acceleration. So, a constant d by dt of sin omega t. What is the d by dt of sin omega t? Omega cos omega t, like math d by dx of sin x model. So, we again differentiation with respect to time. Always in physics, differentiation with respect to time only. Now, see here, student. Say dv by dt, rate of change of velocity, nothing but acceleration. A omega constant. What is the d by dt of cos omega t? Nothing but minus omega sin omega t. Minus out omega into omega, omega square. A equals to minus omega square y. This A nothing but acceleration. So, student, A directly proportional to minus y. This derivation part, now I am giving in short way. You go like that, okay? So, this one actual explanation. You are cutting some unnecessary steps, student. Say, first SHM, same question, same answer, just a slight variation. SHM, meaning simple harmonic motion. A periodic motion, just you are writing like this. A periodic motion with two conditions like this. To and fro. Next, acceleration directly proportional to displacement with opposite direction. That one only simple harmonic motion. Then after diagram, see here, student, X, O, X dash, Y, O, Y dash. A dots nothing but imaginary, theta. Theta, this is Y, this is A. You take any name, no problem, student. OAB I took. From triangle OAB, from triangle OAB, first of all, what is the angular velocity? Omega. From triangle OAB, sin theta. Sin theta equals to opposite side by hypotenuse. A. Y equals to A sin. Direct we are writing omega t. How? Y equals to A into sin theta. Theta equals to omega into t. Angular velocity equals to angular displacement by time. Equation 1. Differentiation. Now, dy by dt, rate of change of displacement, nothing but velocity, equals to A omega cos omega t. Equation number 2. Again differentiation. dv by dt, nothing but A equals to minus A omega square sin omega t. Direct we are writing like this. A equals to minus omega square y, because you write in bracket from 1, equation 1, A directly proportional to minus 5. So, A directly proportional to minus y indicate that particle motion in circular path SHM. All members listen carefully. Previous derivation part, present derivation part, 100% same. If you remember watching few previous, that somewhat big, now somewhat short, both are same. These are mathematical derivation part. For this one, you are writing matter with your own words. Here definition, SHM definition. Here matter, a particle moving with omega angular velocity, XO, X dash, YO, Y dash are the diameters, and that particle making theta angle, let particle at A point. This one all, our convenience we are writing matter. When we are writing matter, automatically that answer size increases. So, this is the main derivation part from SHM. simple harmonic motion. For this one, phase difference, single problem. Sometimes they're asking phase difference problem related to SHM. This is the question number 4. Yesterday I gave one frame, 19th bit, 2 LAQs, 20th bit, 2 LAQs, 21, 2 LAQs, 19th, 2 questions from mechanics, work power energy. Question number 21, 22, 19, 20 from mechanics, 21, 22 from, because I am giving parts, 2 questions, 19th, 2 questions, 20th question 2 from oscillation, 20th question 100% from oscillation, because oscillation weightage 8 marks. How many questions you are reading? 2. One is SHM question, previous question, time period of simple pendulum. So A directly proportional to displacement, acceleration directly proportional to displacement with opposite direction. For this one, phase difference problem. See here, phase difference. See here, this problem from textbook only. See here, students, page number 214 from Telugu Academy book. Problem number 8. Given data, what is the problem they are giving? A simple harmonic oscillator has time period 2 seconds. One simple harmonic oscillator, time period 2 seconds. What is the simple harmonic oscillator means? A device which performs simple harmonic motion. That one only, simple harmonic oscillator. Capital T is equals to 2 seconds. What will be the change in the phase? They're asking change in the phase. Phase denoted with phi. Change, delta coming. Delta phi equals to question mark. Change in the phase angle after 0.25 seconds. Time they are giving 0.25 seconds. So, what is the phase difference formula? Delta phi equals to 2 pi by t into small t. This is the formula for phase difference from oscillations lesson. 2 pi divided by time period. How much time period they gave? 2. Small t is equals to 0.25 seconds. 2 cancel, remove 1 point, extra 2 zeros coming, student. 25 1 ja, 25 4 ja. Pi by 4 radians. This is the phase difference. Delta phi equals to pi by 4 radians. This is the problem belongs to previous question SHM. This is the question. SHM. Particle motion is SHM when particle moving in circular path with respect to diameter. So, student, if you remember, they are getting doubt how that circular motion with respect diameter SHM means. This one just I am giving explanation. Don't write in examination. See here, all of us here. A, B, C. Now see here. So first particle at X point going from X to O. Here A to B. X to O over. A to B over. Again O to X dash. Again B to C. Again coming back. Again coming back. Again going towards initial portion. Again towards initial portion. This is called SHM. Simple harmonic motion means oscillation. Yesterday I gave one example also. What is the meaning of oscillation means? For example, you are moving from house to college. Again from college to house, that is nothing but oscillation. Particle moving from X to X dash, again going towards X, that is called oscillation. Here, particle moving from A to C, again C to A, that is called complete oscillation, required time capital T. That's why we are saying in question, particle in circular path with respect to diameter, its motion is SHM, like this. But you are not writing this one, just a derivation part enough, student. This is the long answer, fourth 3-star question. Up to now, 4 LAQs over. One more time, I am giving that words. You check. First LAQ from work power energy, law of conservation of energy, bullet problem. Second question, same lesson. Define work, kinetic energy, work energy theorem, power of motors. Two problems. 15,000 watts. Second one, 166 horsepower. Two questions from work power energy. Next two questions from single lesson, oscillation. One question, derivation of time period of simple pendulum with 3 cases, ticks of pendulum, seconds pendulum, how much length decreased, 7/16 meter yesterday we did problem. That is the question number 3. Now today, SHM, a particle motion is SHM when it is moving in circular path. So with problem, total 4 LAQs over, more 2 balance. Every student you are reading 6 LAQs. From that 6, minimum to maximum 3 LAQs coming. Here, last 2 LAQs left from this intermediate first year. Fifth LAQ from heat lesson, thermal properties of matter, thermodynamics, there already. Thermodynamics, Newton law of cooling. This Newton law of cooling means thermal properties of matter, LAQ. Newton law of cooling with surrounding temperature with fixed problem. Newton law of cooling with surrounding temperature problem. This is the question number 5. Our last LAQ, reversible process, irreversible process, Carnot engine. So question number 5, Newton law of cooling. Newton law of cooling with surrounding temperature problem. What is the Newton law of cooling means here? First of all, just you take one example. This is the rice. Obviously, in your house, your mother cooking rice. This one rice, meaning you treat hard body. This hard body slowly, you are reading in thermodynamics, hard body loses temperature, cold body gains temperature. Hard body slowly, like this. Always hard body loses temperature, cold body gains temperature. Now Newton scientists suggested how a hard body loses temperature. Hard body loses temperature. Here we are writing statement like this. dq by dt. In physics, anywhere d by dt coming. For example, ds by dt. Rate of change of displacement, nothing but velocity. One more, dv by dt, rate of change of velocity, nothing but acceleration. Rate of change of momentum, nothing but force. Rate of change of angular momentum, nothing but torque. This many rates coming in intermediate first year. So anywhere you take in physics, d by dt coming means rate of change, meaning with respect to time, that given body, that given situation, how it is changing with respect to time. This one d by dt means rate. Rate means 100% with respect to time. Time involvement compulsory. Now concentrate on statement of Newton law of cooling. This one dq by dt. Rate of loss. Why we are using that last word means hot body slowly loses temperature. Loses. That's why we are saying loss. Rate of loss of heat of a hot body. One hot body loses temperature. Rate of loss of heat of a hot body directly proportional to temperature difference between body and surroundings. Here we are writing statement like this. See, rate of loss of heat. Loss meaning hot body loses temperature. Hot body temperature with respect to time slowly decreases. That's why we are saying that word lose. Rate of loss of heat of a hot body. Rate of loss of heat of a hot body is directly proportional to temperature difference in between body and surroundings. This is the statement of Newton law of cooling. Rate of loss of heat of a hot body. Rate of loss of heat of a hot body directly proportional to temperature difference between body and surroundings. For this one, we need explanation. So, dq by dt directly proportional to T minus Ts. What is the T? Temperature of body. T equals to temperature of hot body. Ts, surrounding temperature. So dq by dt directly proportional to temperature difference between body and surroundings. Now depend on this one, some explanation coming here. dq by dt. dq by dt directly proportional to T minus Ts. This is the statement. On removing proportional, we can get constant T minus Ts. Minus indicates that hot body temperature decreases. K obviously constant. This is equation number 1. Sometimes they are giving two temperatures, because this one especially we are using in problem. Two temperatures giving means same formula we are writing. dq by dt equals to minus k into T1 plus T2 by 2 minus Ts. For example, three temperatures coming. T1 plus T2 plus T3 by 3, like that, average mathematically. So this is the formula for two different temperature. Minus indicates that hot body loses temperature. K constant. This is the formula in terms of heat. One more formula we are getting in terms of temperature. Small t indicates time. Now see specific heat. Specific heat, this is the very famous physical term. Specific heat S equals to 1 by m into dq by dt. From this one, what is the dq? dq equals to S m dt. Like this, see, dq by dt means t going left side. dq is equal to ms. Our college name only ms. ms dt. So dq is equals to ms dt. From this one, left and right side, multiply with dt. dq by dt equals to ms into dt by dt. Few members, they can get confused. Small t is the time, capital T is the temperature. D indicates that differentiation, difference coming in problem. So dq by dt meaning ms into dt by t. You substitute here. dq by dt means we are getting ms into dt by dt equals to minus k into t minus s. This constant going right side, again constant. So we are writing like this. See. Constant by constant into constant, we are doing anything. Again constant coming. dt by dt equals to minus k into t minus ts. This is our second equation. Now here students, first Newton law of cooling. Statement of Newton law of cooling. This is the statement. Here, hot body loses temperature, rate of loss of heat of a hot body. Rate of loss of heat of a hot body is directly proportional to temperature difference between body and surroundings. Statement of Newton law of cooling. Then after explanation, dq by dt. In physics, d by dt indicates that rate of change with respect to time. That word only d by dt. Q nothing but heat. dq by dt directly proportional to temperature difference between body and surroundings. On removing proportional, constant coming, minus indicates that temperature of the body decreases. So you write k equals to constant. Now write dq by dt minus k. Two temperatures coming from problem T1 plus T2 by 2 minus Ts. This is the formula in terms of heat. One more formula in terms of temperature. So specific heat S equals to 1 by m into dq by dt. Specific heat is the important concept in chemistry also. Chemistry notation, you are going to take that C notation. C, S, both are same only. S, specific heat, 1 by m into dq by dt. From this one, what is the dq value? ms into dt. Both side multiply with time. Left side dq by dt, right side ms into dt by dt. Substitute here. We can get ms into dt by dt minus k into t minus ts. Right side same step. Constant into going right side means divided. Constant by constant into constant. Again we are getting constant. This is the formula for Newton law of cooling. In this one, two situations coming. One is conditions, because for conditions you can get 2 marks. One is condition, next one is the problem. What is the meaning of condition? Means few situation, few special condition there. For in that few special conditions only Newton's law of cooling applicable. So minimum 2 student, minimum 2 condition you write. See, first flow of heat only. Convection. I will give explanation. What is the meaning of this one? See, two conditions, streamline flow there, uniformly distributed like there are 4 conditions, but minimum 2, because 2 conditions, 2 marks. Flow of heat only due to convection. What is the meaning for this one means? Here, student, this is the hard body loses temperature. Hard body loses temperature means through air. Hard body loses temperature means through air. It is losing. That is called convection. Total 3 types of flow of heat there: conduction, convection, radiation. So convection, flow of heat only due to convection, negligible amount of conduction. What is the meaning for that one means? Flow of heat only through fluids. Fluids nothing but air. Majority people they are thinking fluids nothing but liquids only. Fluids nothing but which flows. Water flows from one place to other place. Fluid. To take air flows from one place to another place. So gases and liquids collectively we are calling fluids. In fluids, which type of motion is there? Flow of heat means convection. That is all our condition number 1. Flow of heat only, convection. Next one is there temperature difference moderate. What is the meaning for this one? Temperature difference moderate means, for example, hard body temperature 100, surrounding temperature 190 there. This difference 90 degrees Celsius. This situation, Newton's law of cooling not applicable. Just a slight variation. For example, this temperature 95, surrounding temperature is there. Here 100 there, 190 means, wait, 1 minute. You take reverse otherwise. Because hard body loses temperature means you go like this. Here 100, here you take 50. Then hard body loses temperature. Sometimes, you know, in winter season, why we are getting cold feeling means, in winter season, our body, hot body, surroundings cold. That's why we are losing temperature. In winter, surrounding temperature is less compared with our body. You take summer, surrounding temperature is greater than our body. Here 100, there 50. Where is the high temperature? Here. Meaning hot body loses temperature, cold body gains. How much variation is there? 50 degrees Celsius. This situation not applicable. 100. You take here 95 degrees Celsius. How much? 5 degrees Celsius. Meaning temperature difference practically less than 5 degrees Celsius. It is applicable. That word only we are writing moderate. Temperature difference moderate. And one more, heat only due to convection. This total Newton law of cooling applicable. Conditions compulsory. What is the reason? For 2 conditions, you can get 2 marks. Conditions, derivation part. One is heat, one is temperature. Now, fixed problem, surrounding temperature. Surrounding temperature problem, 2 conditions with derivation of Newton law of cooling. Total long answer 8 marks. 3-star question from thermal properties of matter belongs to heat lessons. Here, total 6 LAQs. Now we are in 5th. Thermal properties of matter. Every LAQ problem, SAQs, VSAQs. You take any problem from physics, 100% from textbook. Telangana Board of Intermediate Academy book. So, what is the problem? Page number 311. See, question number 3. LAQs, long answer question. State and explain Newton law of cooling. States the conditions under which Newton law of cooling applicable. A body cools down from 60 degrees Celsius to 50 degrees Celsius. Question data. A body cools down from 60 degrees Celsius to 50 degrees Celsius in 5 minutes. 60 degrees Celsius to 50 degrees Celsius in 5 minutes. This is case number 1. And 2, TO2, and 40 degrees Celsius, another 8 minutes. Like this, temperature losing. Find the temperature of surroundings. They gave 2 different temperature. They're asking what is the surrounding temperature. A body cools down from 60 to 50 degrees Celsius. For this one, formula compulsory. dt by dt. Capital T indicates temperature. Small t indicates time. Don't get confused. T, capital T is the temperature. This one temperature difference. This one time. So, here student, here I am writing dt equals to temperature. Small t nothing but time. dt equals to minus k into 2 different temperature coming means formula. I already said average formula. This is the formula. Formula 1 mark compulsory write formula in terms of temperature. Don't go towards heat formula. Now see dt indicates that difference in between temperature. 60 minus 50 by time 5 minutes. You know 1 minute equals to 60 seconds. Equals to minus k T1 plus T2 by 2. 60 plus 50 by 2. What is this line? Say 60 plus 50 divided by 2 minus Ts. Because we don't know what is the Ts, surrounding temperature. Now see 60 minus 50, 10, 300 equals to minus K. 60 plus 50, 110 divided by 2, 55 minus Ts. 0, 0 cancel. 1 divided by 30 equals to minus K, 55 minus Ts. Equation number 1. From this 2 temperature, equation 1 coming, 60 to 50 in 5 minutes. Next, one more case, 50 to 40. In second case, we don't want formula because this formula is same. 50, 40. So temperature difference. 50 minus 40 divided by 8 minutes. 1 minute, obviously 60 seconds equals to minus K 50 plus 40 divided by 2 minus Ts. 10, 480, 90 by 2, 45 minus Ts. 0, 0 cancel. 1 by 48 equals to minus K, 45 minus Ts. Equation number 2. If you remember thinking this much big problem, again I will give in short method student. 1, 0, 0 cancel 1 by 48. So equation 1 divided by equation 2. If you remember taking K value substitution, anything no problem because different methods we are having. Equation 1 divided by 2, we can get our answer. 1 divided by 2. 1 by 30 minus K 55 minus Ts. By here also minus K. Equation number 2, 1 by 48 minus K 45 minus Ts. See, 1 by 48 minus K 45 minus Ts. So we wrote like that. Cancel. Going up 48 by 30 because reciprocal. 55 minus Ts. 45 minus Ts. 6 5 ja, 6 8 ja. Cross multiply you do. 275 minus 5 TS. Cross multiply and this one 360 minus 8 TS. Minus means plus 8 TS minus 5 TS. 8 left 275 right. 360 minus 275. What the balance? 3 TS. Here balance 28.3 like that. So overall, our answer TS equals to 28.3 degrees Celsius. This is the surrounding temperature, student. So problem, they are giving 60 to 50, 5 minutes, 50 to 40, 8 minutes. This much big problem you are doing means, remember, they can get confused. That's why I will give short method. First 60 to 50, dt by dt. Temperature difference by time. Right side, we are taking mathematical steps. Again, temperature difference, 55, 50 minus 40. This average is there. So from equation 1 and 2, we can get 28.3. In examination, this one actual procedure. If possible, you go one more alternate method. Because this surrounding temperature means fixed problem, student. That's why I'm saying given data 60 to 50 in 5 minutes, 50 to 40 in 8 minutes. This is the given data. First formula, dt by dt equals to minus k T1 plus T2 by 2 minus Ts. This formula compulsory, because for that formula you can get 1 mark. Now see, first case, 60 to 50. How many minutes? 5 minutes. Average value. Ten, 300, 55 minus Ts, equation 1. Now see second case, dt 50 minus 40 divided by 8 minutes, because 1 minute is equal to 60 seconds, I am writing, minus k 50 plus 40 divided by 2 minus Ts. What is the balance? 10. 480 minus k 90 by 2, directly you write 45. Students here, direct you see, from 1 and 2, Ts equals to 28.3 degrees Celsius. Direct like this. Because in examination, they are watching 2 steps. This explanation, if you remember, doing shortcut, if you remember enlarged method, they are not watching. First formula, then after surrounding temperature, 28.3 degrees Celsius. So this is the Newton law of cooling. In Newton law of cooling, first statement, then after expression for temperature, then minimum 2 condition, then after problem. Okay, students, this is the LAQs today. Now, last LAQ, tomorrow I'm finishing this total LAQ zone. Last LAQ, reversible process, irreversible process, Carnot engine. That is our last LAQ. One more time, student, just 2 minutes. There were 19th bit. Okay, see, 19th bit only. Two questions. Law of conservation of energy, freely falling body. Bullet problem. 5.4 kilowatts. Define work, kinetic energy, work energy theorem. Two problems, student. 15 kilowatts, 166 approximately equals to 170 HP. Two LAQs important for 19th. Next, time period of simple pendulum. Three cases, ticks, seconds pendulum. That problem 7/16 meter decreased. Three cases coming for simple pendulum time period equation. Next to today topic, define SHM, particle motion SHM with respect to diameter. In circular path. What is the problem? 5/4 radians. How much phase difference? This is the question number 20th purpose, student. Now 21. Newton law of cooling. Newton law of cooling with conditions surrounding temperature. (28.3 degrees Celsius). Up to now, this question finished over. Total 5 questions over out of 6. Now last question, tomorrow topic. Reversible, irreversible process, Carnot engine, Carnot's theory. This one without problem because this is a very big question, long derivation part. Total 6 out of 6, 5 LAQs over, including problems. Last question LAQ, reversible process, irreversible process, Carnot engine. After that, we are going towards SAQs zone. Okay, students, we continue.